So here's the graph of a function. Select all the values that are equal to 0. Okay, yes, Sean. Okay, what do y'all think? Let's look at what y'all put. So some of y'all put A, some of y'all put B, some of y'all put C, some of y'all put D, some of you put E, a couple of people put F. Okay, so we're kind of all over the place. So with that being said, what would be the 0 value for these 2 points? B and D, right? Okay, what about this one right here, which would be the, so it should have been B, D, and E. Okay. All right, number 2. Here is the function from the previous screen. Its equations is f of x equals x plus 2 times x minus 3. Graph the x and y intercept. So you should be able to graph them. So what do they look like?
X equals 2.
Okay, so go ahead and graph them. Take a second, and then I'll check your work. And here, they're asking for the intercept. So that's where it crosses the x-axis and the y-axis. Okay, so let's say that we plugged in 4. I don't know, because 4 is a good number. If we plugged in 4, this is what it computed. We get 6. If we plugged in 3, we get 0. What intercept is this, x or y? Okay, so this is going to be an x-intercept, right? So that's going to be this guy right here. Okay, so what other number would be an x-intercept?
5.
Okay, so if we plugged in 5, do we get 0 at the end? No. We need this number over here. What number would that be roughly? Okay, -2. Let's try that. Oop, there we go. It gives us 0. So is that an x-intercept? Yes. Yes, it's an x-intercept because it has a y value of 0. So we're looking for this. That would give us an x-intercept. How do we find the y-intercept? We plug in what? We plug in what for x? 0. And when we do that, that's going to give us -6. Look at that point right there. It filled it in. So we just graphed these 3. So it would be this, this, and this. Really quick, look at what we plugged in for x, for our x-intercept, and then look at what the original graph or original equation looks like. Okay, here it is again. Look at what our x-intercepts are.
It was a y-intercept.
Look at what our x-intercepts are, and look at what our equation is. Okay, there's a similarity between those. So what do you notice about the intercepts? Go ahead and write that out. All right, so some of the things that you came up with were, I don't know. I noticed that the x-intercept is the same, but with opposite sign. Man, y'all let that blink. Come on.
Y'all, it's y'all. I answered it. I answered it.
Yeah, we're just.
No. Nope.
No.
So what do you notice between this value and what the x-intercepts are? Somebody said it. It's the opposite sign. So again, right here, this is the important part. So if you haven't been paying attention, this is the part. Look at how it's a +2 here, but it's a -2 here. Look at how it's a -3 here, but it's a +3 here. Okay, so it's the opposite sign when you're finding the x-intercept. Good talk. All right, slide 4. Here's a new function. Graph the x and y intercepts by entering their x coordinates in the table. So looking at this, what could potentially be our x-intercept? What do you think it's going to be? Using what we just learned on the last slide, what is this one going to be? 5. It's going to be the opposite of this sign. So it's going to be 5. And when we compute it, it's going to give us our y value of 0. And there it is.
Oh,
What about this one? We've got a 2x minus 6. Well, if we plugged in 6, because somebody just said it, do we get 0? No, we get 6. What if we took the equation and set it equal to 0 and solve? What would we do first? What would we do first?
We got on the other side, bring the negative 6 to the other side.
Bring the negative 6 to the other side. And then what's the next thing? Divide by 2. So that would give me x equals 3. Let's see if that works. If we plug that in, that gives us 0. So is that an x-intercept? Yeah. Okay. What about our y-intercept? How do we find that? So we plug in 0. That gives us 30. There you go. Questions on that? All right, so Raven's work from the previous challenge. She found that an x-intercept is at 5. She says that there will be another one at 6. What did she do wrong? What did Raven do wrong? Yes, Sean.
He didn't use opposite sides.
She didn't choose opposite sides. Okay. Well, we saw that she said x equals 5 here, right? And then she said x equals 6 for this one. Is that true? Why? So she didn't do the whole setting it to equal to 0 and then solving, right? Really, that's what we're doing here. That's why we get the opposite sign. So we have x minus 5 equals 0. If we move that to the other side, that's where we get x equals 5. That's where that comes from. Okay, looking at slide number 6. We want to find the x-intercepts and the y-intercepts. Go ahead and take a moment, see if you can fill that one in. Okay, so let's take a look at somebody's work. Somebody said 0.5, comma 0. So that would be right here. And then negative 2, comma 0. That would be right here. And 0, comma 4. That would be here. One thing that you got to pay attention to is the fact that we have a negative x plus 0.5. If we set that equal to 0 and we solved, and then we divided by negative 1, that would be x equals positive 0.5. So just because you're going to switch the sign, you got to make sure that you pay attention to whether x is positive or negative. Okay? All right. Won't let you what?
So how did you get?
I can see whether or not it's right or wrong. Yeah.
How did you get the blenders?
How did I get the y-intercept? I plugged in 0 into the equation, and that gave me my y-intercept. All right, settle a dispute. 2 students were asked to determine the x-intercepts. Yolanda says the x-intercepts are at -2 and -9. Julian says the x-intercepts are at 0 and -9. Who is correct? Take a moment, decide. Okay, so let's see what you came up with. Most of y'all said that Julian was correct. Thank you to those of you who actually attempted it. So, why is Julian correct? Well, if we take 2x and we set it equal to 0, what will we get? We would divide by 2 and that would give us 0, right? If we took x plus 9, set it equal to 0, we would get x equals -9. So Julian is correct.
Wait, that's all we gotta do?
Yep.
So we just take that, I'll get the 2x outside of there, and we just say it's 0.
Yep.
Wait, what?
Bro, this is so easy. Why would that
Wait. What?
All right, take a moment, look at the next one. Try to find the x-intercept. All right, so let me make your lives a little bit easier. Do you remember those little diamond problems that look like this?
Yeah.
Okay,
Oh, yeah.
so how would you complete this one?
You multiply.
Multiply to get you -10, but add together to get you 3. So what 2 numbers would make that happen? Multiply to get you -10, add to get you 3.
Negative.
5 and -2, right? Okay. So let's think about that. Look at this. Where is this located roughly?
-5.
-5. So let's plug in -5 in here. And when it computes, guess what? That's the x-intercept. What about the other one? What would this be? Positive 2. Let's try it. Okay, and that would give you your x-intercept. You see how those diamond problems are related to this problem? We'll look at it really quick. What your B term is going to go down here. And what your A times C term is going to go up here. So everybody see that? Okay, so if I plugged in 0 into this equation, that's going to give me my y-intercept, which is -10. Notice how your y-intercept is this last one right here. So we see how all those pieces are going together. Okay, in this next part of this unit, this is what's going to come up. You got to be able to factor. That's what that's called. All right, looking at slide number 9. This table shows the x-intercept and y-intercept. Which intercepts are easier for you to determine? Which one do you think? X or y-intercept? Click one. Click one. X or y-intercept? So some of y'all are saying x-intercept. I personally believe y-intercept just because all you have to do is plug in a 0. The other one we had to do like 3 steps. Okay. All right, on slide number 10, what I want you to do is match the y-intercept with the equation. Match the y-intercept with the equation. Okay, I'm going to give you about 8 minutes to do this, and then we're going to check. Okay, so majority of you have not finished, which means that either A, we don't know what to do, or B, we haven't even tried it. So if I want to figure out whether or not something has a y-intercept, I'm going to plug in 0 for the x's. For instance, this guy. If I plug 0 in, that means I'm going to put a 0 in for every x value. So what's 0 squared? And 5 times 0? So then that means that I would have a y-intercept at 0. Do either one of these have a y-intercept at 0? Don't say yes. No. Okay, so that doesn't work. I'm going to try this one. I'm going to plug in 0 for x. So we have 5 times 0 squared minus 3. What's 0 squared? 0. 5 times 0 is? What's 0 minus 3? Okay, so this works for this guy. That's all you're doing. Please stop making things difficult. On the next one, we've got 3 times 0 plus 5 plus 0 squared. What's 3 times 0? 0 plus 5 plus 0. What is that going to be? 5. That goes right there. Can you finish those last 3 cards? 2 of them are not going to match up to those cards. So again, this is going to go here. This is going to go here. Finish these last 4. Let me show you a cheat code way to do this. If something is written in standard form, then whatever the value is at the very end, that's your y-intercept. Okay, so for instance, this guy is going to have a y-intercept at -3. This guy is going to have a y-intercept at 5. This guy is going to have a y-intercept at 5. Oh, we had this conversation. Standard form is where it's written like this, where it's ax squared plus bx plus c. So it's written out with the addition in between. C is your y-intercept.
There's no quotation on the
I don't know what that is.
road.
Okay. All right, go ahead and go to slide 11. What does each form tell you about the graph of f? So standard form, what can we find out from that? Factored form, what can we find out from that? Take a second, fill that out. So some of y'all said that the last number on standard, keep your hands to yourself, please. The last number in standard form is the y-intercept. And then factored form, we can find the x-intercepts, right? So we could take those, set them equal to 0, and then solve. Okay, that's what we did at the very beginning. Okay. Slide 12. I want you to go ahead and take a moment. What are the x-intercepts and what are the y-intercepts of each of the functions? So they wrote it out in standard form and they wrote it out in factored form. So go ahead and take a moment. Work on. So how well did you understand today's assignment as well as like the learning? Okay, so here are the answers for slide 12. And then go ahead and answer slide 13. And then once so light up the parabola by zapping a few points on it. Its equation is this. Okay, so zap. Oh, that's kind of cool. Okay, so what would be another point?
2, 0.
Okay, 2, 0. And zap. All right, what would be another point?
0,
0, -4. Zap. That's kind of fun. Yay. Yay, we made it light up. It looks like a lightsaber. It's kind of cool. Have y'all watched the new Star Wars series?
Yeah.
No? Okay, yes.
Isn't it?
No, it's the Ashokoa. No, I'm saying that wrong.
Oh, that one? Oh.
Trash. Anyways, all right. Light up the entire parabola by zapping points onto it. All right, so what is this going to be? What's going to be the x-intercept for this first part?
What?
-1, 0. Do we see how we flip the sign? Zap. Excuse you. There we go. Okay, and then what about this next one? This one's a little tricky. Okay, why did you get 3 and not -3? Because it was again. Thank you so much. All right. So what he really meant to say was, since I have -x plus 3 equals 0, I'd move -3 over to the other side and then divide by -1. So that would be x equals 3. Good job, Sebastian. Yay. Okay. Then how do I figure out what my y-intercept is? Because this isn't written in standard form, but what could I plug in? 0. Okay, cool. Oh, so good. All right, so if I plug 0 in here, that would give me 0 plus 1 times 0 plus 3. So what's 0 plus 1? What's 0 plus 3? What's 1 times 3?
3.
Okay, so that's going to have a y-intercept of 0, 3. Yeah. Look at it. Look at it. Okay, well, first of all, okay, so how do I figure out another point? Oh, we already found our x-intercepts. So this little gap right here, what's my x value there?
3.
Try again. This x-intercept right here. 2. So we're going to take 2 and we're going to plug it into our equation. So if we take 2 and we plug it in here. So what's 2 plus 1?
3.
Oh, wow. Thanks, guys. All right. And then what's -2 plus 3? 1. So what's 3 times 1? Okay. So I'm going to type in 2, 3.
Wait, what? Where'd you get the 2 from?
Because we said this piece right here is missing. You told me that that has an x value of 2. Plug that in. Yeah. And look. Yeah. Look at it. Looks like the McDonald's symbol, sort of. Might be a little hungry. It's fine. All right. Maria and Layla compared their strategies on the previous challenge. Maria said, I used 4 zaps. Take a look at my graph. Layla said, we used some of the same points, but I only used 3 zaps. What 3 points do you think Layla zapped? Well, she probably did the x-intercepts, right?
I think she did 1, 4.
So she said here, here. And then why do you say 1, 4? What is that called? Ah, there it is. The vertex and the x-intercept. You're typing that in. Type, type, type. Where's the vertex? Here are the x-intercepts of a new parabola. Drag the points to show where the vertex could be. So the vertex has to be equidistant in the middle of those two x-intercepts. Okay, so let me say that again. The vertex is in the middle of the two x-intercepts. Okay, so where could that potentially be? Well, it could be right here, it could be right here, it could be right there, there. All right, so what do you notice and wonder about the vertex? Hey, so y'all said that it's a straight line going down. There's dots going vertically. Why are the dots going vertically? It's in the middle of the 2 points. Good. Vertex has to be somewhere in the middle. Fantastic. All good answers. Okay, on the next one, it says here's the parabola from the previous screen. Complete this parabola by zapping its vertex. So what would the vertex be on here? Has to be equidistant, right? So what would be the x value on this guy? What's in between 1 and 2? 5. So what's in between 1 and 5? No, 1 and 5. 3. Okay, so when x is 3, what's our y value? Well, let's plug 3 into our equation. So we're going to get 3 minus 1 times 3 minus 5. So 3 minus 1 is going to give me 2. 3 minus 5 is negative 2. So what's 2 times negative 2?
Oh, -4.
Okay, so this is going to be 3, negative 4. Zap. Look at it. Gorgeous. Okay. I don't even know how to say this person's name. Here is Tyler's work to determine the vertex of G. She completed part of the table before getting stuck. What does the 3 in the table represent? And how can you find the y coordinate of the vertex? What does the 3 represent here?
And
The x.
intercept.
Here are the x-intercepts. So it's between 1 and 5. What's our x value in between 1 and 5? 3. So what does this represent? The x value for the vertex. X value for the vertex. Now, how can you find the y coordinate? What can you do? Plug it in, plug it in. I know Glade plugin. You plug it in. So 3 minus 1 is going to give us 2. And 3 minus negative 5, 3 minus 5 is negative 2. So 2 times negative 2 is negative 4. So you can plug in to find the y coordinate. Crisscross. Okay, light up the entire parabola by zapping the points on it. Use paper to help you with thinking. So what are we going to find here? What are we going to look for? The x-intercepts. Great. And the vertex. Awesome. Y'all are so smart. No. Thanks, guys. Appreciate it. X-intercepts. And then go ahead and plug in for the vertex. Okay, so take a moment. See if you can do slide number 7. All right, so on this one, how do I find my x-intercepts? Well, I set both of these equal to 0 and I solve. So 2x plus 4 equal to 0. I would move the 4 to the other side. And then I'm going to divide by 2. So we have an x-intercept at negative 2. So I've got negative 2 comma 0. Zap.
And I got 4. And 2, 4.
Then we're going to take x plus 6 and set it equal to 0 and solve. So x plus 6 equal to 0. That's going to give me x equals negative 6. So we'll get negative 6 comma 0.
But how does 6 plus x equal 0?
We set each one of these equal to 0, and then we solved. So we subtracted 6, and so that gets you x equals -6.
Oh, okay. So it's an inverse operation.
Yes. All right. The last thing we're going to plug in is 0 in for all of our x's because we're trying to find the vertex. So when we plug in 0, we're going to get 2 times 0 plus 4, and then 0 plus 6. Well, what's 2 times 0? 0 plus 4 is 4. 0 plus 6 is, so 4 times 6 is 24. So we're going to have 0, 24.
Oh, if I got a quiz right now, I'll get it.
Makes sense. Now, that's just to find the y-intercept, but did that help us at all? We're not done with the entire graph. How do we find the vertex? How do we find the vertex?
Common point. A wider stuff.
Vertex is located in between which 2 points? X-intercept. So what number is in between -6 and -2? -4. All right, so if I plug in -4 into this equation, what do I get? Well, that's going to give me 2 times -4 plus 4 times -4 plus 6. 2 times -4 is -8 plus 4 is -4. -4 plus 6 is +2. So this is going to give me, thank you. So this is going to give me -4, comma, -8. And then if I zap that, ta-da, yeah. Does that complete an entire graph? Yes. Remember, you only need 3 points in order to make a graph. So describe the strategy we used in order to graph that. So take a moment. So what strategy did y'all use? So what did we do? Yes, Sean.
So I did 2 times 0.
Okay.
Wait, I did 2 times 0, and then there's an x over there, and then I did 2x plus 4 equals 0. I subtracted 4 and I got 0 and divided it by 2.
Okay.
And then I got -2, 0 for the first one. And then I did the same process, and then I got -6, 0.
Okay. Or you could use Desmos, or you could, exactly what he said, take each one of the factored forms and then plug it in, set it equal to 0 and solve. Or you could plug in 0 and get the y-intercept. You could also get the vertex, okay? Go ahead and take a moment. Try slide number 9. We're trying to line up the entire parabola. So this one, I want you to try completely on your own. Find the x-intercepts, find the vertex, and find the y-intercept. Okay, take a moment, try that. So on number 9, if I was going to find the x-intercept, that would switch both of these signs. So that would be 3 and -1. Okay, 3 and -1. Okay, then I would also find the vertex. How do I find the vertex?
The line in between the x's.
Line in between. So this is going to be from -1 to 3. What's in between that?
-1. 2.
So 2.
Yeah.
Okay, so if I plug 2 in here, that would give me 2 minus 3 times 2 plus 1. So that's going to give me -1 times 3. So that's going to give me 2 comma -3. Again, you could use Desmos on here. But, was that the vertex? It was in between?
Yeah. The vertex is in between.
Okay, so let's try this again. Was it this point right here that I found? No. So what is in between -1 and 3? What's in between -1 and 3? Halfway between.
2.
We just tried to.
1.
So remember how we did that number line? -1, 0, 1, 2, 3. What's in between?
1.
Okay, so if I took 1 and I plugged it in. If I took 1 and I plugged it in, I would get 1 minus 3 times 1 plus 1. So this will give me -2 times 2, which is -4. So this is going to be 1 comma -4. Okay. We need to have this conversation really quick. The axis of symmetry. What that is that's the vertex's x value. So for instance, on this one, it's x equals 1. That's where you can divide the graph in half. Okay, so go ahead and take a moment. Go ahead and skip to slide 12. Go ahead and skip to slide 12. Okay, and go ahead and answer that question. How does knowing the x-intercepts in the vertex help you graph the quadratic function? Which I'll come up with. Yep. So we can figure out plot points. We only need 3 points and boom, done, right? Okay. Go ahead and determine the x-intercepts and the vertex of this. If you are able to do this, you should be okay for Monday. Remember, there is one question on there that asks about axis of symmetry. Axis of symmetry is the x value for the vertex. Okay, take a moment. You're trying. All right, so let's check your work. Okay, so she said, what? Okay, so on here, we're trying to find the x-intercept. So look at this. We're trying to find the x-intercept. So this is going to give me x equals -2. And then this is going to give me x equals +4. What do I get positive for instead of -4? -5. That's a negative. So that's going to be x equals 4. Now, how do I find the vertex? Well, it has to be halfway between these two numbers. So between -2 and 4, what number's in between? 1. If I plug in 1 into the equation, I'm going to get, you did do this part right though, 9. Okay. Questions on that? So it's 1, 9, -2, 0, and 4, 0. All right. Go ahead and answer slide 14. Tell me how you feel about this.